A capacitor has plates that are 2 micrometers apart with an E field of 100 kilovolts per millimeter between the plates. The charge magnitude on each plate is 500 microcoulombs. Determine the capacitance. So let's talk about how to solve a problem like this. Essentially, the approach you want to use is very similar to what you would use for kinematics, which is to say you write down what you know. And so in this case, we know, okay, Q is 500, that's microcoulombs, so that's times 10 to the negative 6 coulombs. I know the distance between the plates, that's 2 times 10 to the negative 6 meters. And I know the E field, that's 100 kilovolts per millimeter. Okay, kilo is times 10 to the third. So this is 100 times 10 to the third volts. Now millimeter, milli is 10 to the minus 3. So this is all divided by 10 to the minus 3 meters, which works out to be 100 times 10 to the sixth volts per meter. And we're looking for the capacitance. Okay, now, much like kinematics, we also want to just see, okay, what formulas do we have? Let's start looking at the formulas, see which ones can work out. So C equals Q over V. This is our general formula for capacitance. Can we use this? Well, not right off the bat. I mean, I have Q, but I don't have V. And you can go and look at the other formula that we have for capacitance. C equals K times epsilon naught A over D. Well, this is even worse. I have D. We know D, but we don't know A and we don't know K. Epsilon naught is a constant, so we do know that. But we don't know K, we don't know A, and of course we don't know C. So that's 3 unknowns. Over here I only had 2 unknowns, but here I've got 3, so that's even worse. Okay, so let me go back to this first formula. Is there some way to get V? Well, I know that the voltage between the plates can be expressed as the electric field times the distance. Aha! I do know the electric field. We know that's 100 times 10 to the 6 volts per meter. And I do know the distance, 2 times 10 to the negative 6th. So, right off the bat, I could use this formula here. V equals, this is 100 times 10 to the 6th. That's volts per meter, times my distance, which is 2 times 10 to the negative 6 meters. Okay. And multiply those together, and that's just going to be 200 volts. Okay, so now I come over here back to my capacitance. Q is 500 times 10 to the negative 6th divided by 200. And you just plug this into the calculator and you get that C equals 2.5 times 10 to the negative 6th farads, or you could say it as 2.5 microfarads.